Okay, so today I'm going to talk about the Newton law of gravitation. So basically our topic is gravitation. What is gravitational force and what is Newton law of gravitation? But before moving ahead, we know that every object in the universe attracts every other object in the universe, which is directly proportional to the product of their masses with their centers. We start considering it, we consider to center, which is directly product of their masses from the center, like this, something like this, and from here as well, which is directly proportional to the product of their masses and inversely proportional to the square distance between their center, which is square distance. We know that every object attracts every other object in this universe. This is Newton's law of gravitation, which is also known as inverse law, 1 upon r square. So what's the statement of this law? Where we can write here, that would be convenient to write. Okay, so let's write every other object in the universe, every object in this universe attracts the every other object with this which is directly with every other object which is directly proportional to the product of their masses and inversely proportional to the square distance between their center. So this is basically a statement of this law that every body in the universe attracts every other body in the universe, which is directly proportional to the product of their masses and inversely proportional to the square distance between their center. So that we have seen here as well. So basically this gravitational force is constant throughout the universe. We can see one picture here that I will explain with the help of that picture. So let's see it here. The picture, let me just code it. Okay, so let's open this picture. Okay, maybe it's unable to get a picture here. So let's make it screen full. Then I can explain you how the gravitational law was formed. Basically, it was formed in a way. Let me show you how it was formed. Firstly, the gravitation law is not something that the apple fall on the head of the Newton and then he formed the law. No, this is basically a work of the scientists, a group of scientists. Firstly, Kepler did study about this, showing the electrical path which is followed by this heavenly bodies. Then the Kepler's work, Newton followed his work, and then he formulated the law, which is this law, which is throughout the, this law cannot be denied. Oh my God, it's right here. So this law cannot be denied. It's just universally constant law, right? This is basically a law which is scientifically proven, right? Which what it says that every body in the universe attracts every other body which is directly proportional to the product of their masses and inversely proportional to the square distance between their center. So nothing in the universe can deny this law because this is universally accepted, right? So let's erase it. Okay, so let's erase this law, not law but this picture, this as well. So let's discuss it. Okay, this is basically only an attractive law, right? This is basically attractive law. This is basically attractive forces, not repulsive forces. These are only attractive forces. These are only attractive forces, not repulsive forces. I can delete one picture from here so that we can have a next space. Okay, let's delete this picture from this here. So let's delete it so that we can have enough space to write the certain points here. So let's start writing these points from here. The first point is, this is basically attractive force. This is an attractive force. Okay, how this is attractive force? For a while, consider these two bodies which are placed here. Let me take any other color. So let's take this color so it will be prominent. Let's do it. For example, this is mass 1, this is mass 2. So every body in the universe attracts the every other body. As you can see, this body attracts this body in a such way which is directly proportional to the product of their masses from the center. This body is only attract from the center. If these bodies attract this body from here, if from here, no, we only consider from the center of their masses, right? So first is this is the attractive force that you have seen here. How it is attractive force? Two bodies attracting each other from the center of their masses, something like this. Two bodies are attracting each other, right? So second statement, this is valid for point masses. This is valid for point masses. Now what is mean by this is valid for point masses? Let's see here what is mean by this is only valid for the point masses. Let's consider that these are the two bodies. For example, this is a sun. This is a sun. I know it's not perfectly so. And for a while, consider this is the earth. So they are placed far apart from each other. They are not placed, nearer to each other. If these bodies are placed nearer to each other, the gravitational force won't work significantly, right? So these two bodies are placed far apart from each other, so that they seem like a point masses. Like if you just observe sitting here or sitting here, don't sit here, just from here, considering as it's this point as reference, so you would consider or you will see it as a point masses. You will consider this as a point masses. So this body, for this law is only valid for the point masses and significant for the heavenly body. This is one heavenly body, this is two heavenly body. They are placed far apart from each other, so this force act upon these forces. For example, this is one boy or a one man, and this is other man standing together with each other. They both are friends. So for a while, consider that now this force won't work here because their masses are so negligible. Like it has a mass 10 kg, he has a mass 10 kg, and then he has a mass, for example, 50 kg because he is fit, or we could say that he is healthy and fit. So 50 kg. For a while, just consider it. So this force will not work here just because their masses are negligible, and this universal law of gravitation or a gravitational force is constant throughout the universe. It's constant that we will see later on as well, but this force is constant throughout the universe, and the value is 6.67 multiplied by 10 to the power minus 11, and then Newton meter square per kg square. Newton meter square per kg square. This is a unit of Newton law of gravitation. So yeah, so this is valid for the point masses. We are done with this point as well. We have proven how this is significant for the point masses. So let's move to the point number 3. What does it say? So let me erase it. Wait. So let's erase it. Okay, so maybe it needs to erase itself. We are done with this explanation. Okay, so let's erase from this part as well. So and let's change the color. So yeah, I think we must change color. So let's take a parrot, something like this. It's not parrot color, but let's take it. So the next point is, oh I'm sorry. So the next point comes here. First, let me erase it. It's messy. As I have told you that this is value for point one, significance for the heavenly bodies, and the other is this is independent of medium. OMG, what's happening?